All right, we're going to look again. I know we covered this recently in class, but wanted to take another minute to look at the key features of quadratic functions. At the top of your page here, you'll notice that there are three different ways that we have that quadratics can be written, whether that's factored form. Remember, that's typically where we've made the x, and then from the x, we've created two different sets of factors, and then those are ways that we can find zeros. You've got vertex form. A open parentheses x minus h all squared plus k, where h and k are the location or the ordered pair, the numbers in the ordered pair that give us the vertex. And then lastly, we have standard form ax squared plus bx plus c, which is what most of what we see are written. The graph of a quadratic function is called a parabola. Remember, that's that interesting shape that we see when we are graphing quadratics. It looks like sometimes a U or a V, but it's called a parabola. Okay, if positive, so if our quadratic is positive, then the graph opens up. If my quadratic is negative, again, my graph opens down. Okay, and then we're going to look at a few key features of those. And if you look on the left, key features are X-intercepts, which are often called roots or zeros or solutions. And it is just where that graph touches the x-axis. That's where graph touches x-axis. And there could be 0, 1, or 2 of those in any kind of quadratic. And again, it has to touch the x-axis for there to be a root, a 0, or a solution. The y-intercept, again, like most things, is often called the initial value. And again, it's where the graph is going to touch the y-axis. And in our scenarios for Algebra 1, the graphs are going to be functions when we see them as a parabola, and so they will only touch the y-axis one time. All right, remember the vertex. The vertex is the very center of the parabola. It's part of what splits that parabola, and so into symmetrical parts. So the vertex is either a maximum or a minimum. And then lastly, the axis of symmetry is the invisible dotted line that splits it in half. You have to excuse my handwriting, but the invisible dotted line that splits the parabola in half. That's the axis of symmetry. So if we go over to the graph itself, our top left box obviously is pointing to our x-intercepts or roots or our zeros. The next box below it, where that graph touches right here, would be our y-intercept. The top right, of course, we have our vertex. In this case, our vertex is a maximum because it is at the highest point. There's nothing above that, so our vertex is a maximum. And then lastly, at the bottom, our dotted line is our axis of symmetry. And I'm going to abbreviate that with the axis of symmetry. All right, I'm going to take the first one, and I'm going to walk you through finding that, and then I'm going to let you work on the second one. So it says find each key feature of the graph below. All right, so first thing I'm going to look at, is it positive or negative? Well, I know because the graph opens down, we have a negative graph. Okay, our x-intercepts are right here and right here. So x equals 0 and x equals 4. And remember, those are not put together as an ordered pair, but they are two separate places where our graph touches the x-axis. The vertex in this case is going to be right here, and our vertex is located at 2, 2. And in this one case, our x or our y-intercept is in the same location as one of our zeros, and so it's at the origin, which is found at 0, 0. All right, and then last but not least, we're going to be looking at our axis of symmetry, and remember that's a vertical line that's going to split our graph in half. It will always go through the vertex. So since our vertex is at 2, 2, we're going to take the x value of our vertex, and that gives us our axis of symmetry equation. So it is x equals 2. All right, go ahead and take a second, pause the video, and then I want you to try to find the 5 key features on that second graph. Okay, so hopefully you got a chance to look at those. Let's go over those just to make sure. Number 1, this graph is positive. It opens up. So the arrows are pointing up, so it is a positive graph. That's going to help me when it comes to the vertex, knowing that it's either a minimum or a maximum where that's located. All right, going to X-intercepts, like we did before, we've got one right here, which is at -4. And then our other one is here at +4. So x equals 4 and -4. Again, our vertex is that spot where the graph changes directions. So from left to right, it's going down from the left. It gets to the vertex, and then it starts going up as we pass the vertex. In this case, our vertex is located at 0, -8. That is our vertex. Our y-intercept in this case is also going to be where the vertex is. And so the y-intercept is also 0, -8. And again, this doesn't always happen. It's fairly rare that one point is going to cover two different things, but it can happen, and it does. And so these are just a couple of places where it happens to work that way. And then last but not least, our axis of symmetry, as a reminder, is a dotted line that goes through the vertex. And so in this case, it is the y-axis. So that's a place where x equals 0. And again, that can be found from the first number in the vertex. All right. And now it says it asks us to make a table of values to graph each of the following and find the key features. Obviously, there's not a ton of space to do these things, but for the key features part, what we want to really do is just mark those, make sure we know where they are. And again, we don't have to find a table of values. We can actually just type the graph into our calculator. So if you go to desmos.com/calculator, you can actually type in the coordinate. If you have your TI Inspire calculator, you can do the same. And then that's going to give us all the things that we need to help us find. So the first thing we're going to do is we're going to go ahead and graph that. So if you've graphed it, x squared plus 4x plus 3, you're going to see, and I'm going to switch over to black here, but you're going to see that the vertex is at -2, -1, that our zeros are here and here. And then we want to find just some common places. And so what you notice when you graph, or what you should notice, is that these points on this graph are going to mirror each other on each side, because again, that axis of symmetry is the reason behind it. So there we go. All right, again, we're going to identify those items. So all along, we've made our x-intercepts black, so we can leave those that way. They're right there and right there. So at -1 is -1 and -3. Again, this graph opens up because it's positive. Excuse me. Our vertex can be found where it's blue, which is at -2, -1. And then our y-intercept is right here, which is at 0, 3. And if you notice that 0, 3, because this is in standard form, is going to correspond with the 3 right here. That 3 at the end of our quadratic in standard form is going to give us the y-intercept. And then our axis of symmetry, we would use the x value from our vertex, and we would say that x equals a -2. And so that invisible dotted line would go vertically through -2. All right, our second equation is actually written in what we call, in vertex form. So from that, we can actually find the vertex. So if you go back to vertex form, it says x minus h all squared plus k. So it's supposed to be minus. So since it says -3, that means our vertex x coordinate is at 3. And then we go to the k number to get our vertex y coordinate, which is going to be +4. So our vertex is going to be located at 3, 4. So we could go over 3 and then up 4. We would put a dot. Now, the other thing that we want to keep in mind is this negative right here. That negative tells me that my graph is going to open down. So I know that I'm going to be looking at a graph that goes down. All right, and then because that's my vertex, and then what we're going to notice is that because it's just x squared, our next points are going to be over 1 and down 1 from that. So my next point would be there, and then it would be from the vertex over 2 and down 4. And those are the points we would need to graph. So then again, I would graph my quadratic and do that. And again, if I needed to, I could go to my calculator to go to desmos.com/calculator, and it would give me all of those points. So when I looking again at my options, my zeros, so x equals a +1, and it also equals 5. And again, we don't want to put parentheses around that. We don't want to make it an ordered pair, just two different locations. All right, then we can't really see it. It kind of goes out of the way. I didn't quite curve it correctly, but my graph has a y-intercept of 0, -5. All right, so we've got those points. And then lastly, we just need to come up with our axis of symmetry. And again, that would be a dotted line like so. And so that would be x equals 3. And again, my vertex in this case would be a maximum. All right. And then for our very last one, it's in factored form. So it starts with a 2, and then it's open parentheses, x minus 3, close those parentheses, and then open parentheses, x plus 1. And from that, we get the factored form. The nice thing is that we can get the x, we can actually, from this factored form, we can get our x-intercepts. And if you look, it says x equals, or x plus 1. So if we set that equal to 0, then x would have to be -1. So one of my zeros is the opposite of what I see in the parentheses. So instead of 1, it would be -1. The other one says x minus 3. The opposite of -3 would be +3. So that would be the location there. All right, if I go to, if I type this in on Desmos.com or my TI Inspire calculator, I would see that my y-intercept would be at 0, -6. And then my vertex would be at 1 and -8. So that would be my vertex right there. Then again, I would take my pencil and I would draw my graph. I have a point right there. Then again, we'd find those key features. So again, x equals -1 and x equals 3. Those opposites of what we see in our factored form. Our vertex is at 1, -8. Our y-intercept is at 0, -6. And then our axis of symmetry would be that dotted line that goes through 1. So then it would be x equals 1. All right, so just some things that we can do there. All right, now, again, we're going to look at these things and we're going to find the vertex in A as we look. So we're just looking at some different forms and different ways to find these things. And we're not going to go through all of these, but I wanted to go through a couple of them. So we're going to say find the vertex and the A. And again, A is what we're multiplying by. So if we look at number 1, we've got 2 in front of x minus 2 all squared plus 4. Well, that's in vertex form. So when we have vertex form, what we want to do is we want to make sure that we pull out those numbers for the vertex. So I've got x minus 2 and plus 4. So that makes my vertex 2, 4. So I'm taking the 2 from this minus 2 and the plus 4. Remember, it's the opposite of what we see in the parentheses. So that's 2 and then 4. So right 2 and up 4. And in this case, because our graph is positive, it's going to open up. All right, going to the second one, we've got a negative out front, so that means it's going to open down. And then my vertex, again, is going to be the opposite of what I see. So since it says plus 3, I know that's going to be a -3. And then we have a -5. So my vertex would be at -3, -5. All right, going to our third one. Vertex, again, I've got a -1 and a -2. So the opposite of -1 is 1 and then -2. So my vertex is at 1, -2. I've got a negative sign in the front, which means that my graph is going to open down. And so that's just another way that we can use that. Again, you can graph it. That's always the best way. If you're not sure what happens, if you don't know for sure, please, please, please graph. Don't guess. It's much better for you to graph and see what's actually there than it is to guess and be wrong. All right, again, it says we've got a graph in vertex form. So we're going to identify some of the key features. We're going to graph it first. So when I do that, I'm going to go and see what I have. So first thing I'm going to do is I'm going to identify where my vertex is. So it tells me here that my vertex is found at 4, 8. Again, that says -4 and plus 8. So I would go over 4 and I would go up 8. And I would put a dot. That's going to be my vertex. Okay, and then what I would do really is I would go to my calculator and I would type it in. Okay, now because it's negative, that means it's going to open down. Normally what happens is when I put a 1 in and I square it, it becomes 1. And when I put a 2 in and square it, it becomes 4. Well, because of this multiply by 2 here, it's actually going to double that. So when I go to the left 1, instead of going down 1, I'm going to go left 1 and down 2. It's going to go twice what it normally does. Right 1, instead of down 1, it would be right 1 and down 2. And then normally when we go over 2, 2 squared is 4, so we would go over 2 and down 4. But because that's doubled, it's going to be over 2 and down 8. And then same thing here, it's going to be over 2 and down 8. Again, we can put that in our calculator, hit Control-T, or we can go to Desmos.com and look. Just make sure that you pay attention to the numbers on the grid to make sure that you aren't guessing incorrectly or you're not counting by ones if the calculator or the system is counting by 2s. So again, we know that it opens down. That makes our vertex a maximum. And again, the vertex is located at 4, 8. The axis of symmetry would be x equals 4. Our x-intercepts would be located at 2 and 6. And then we would have to go a long way to get down to our y-intercept. It actually goes beyond what we can get to, but in the graph we would see that it's at 0, negative 22. All right, what we've done is we've left 8 of them for you to identify some of the key features. Again, you don't have to identify all of them, but it's really important that you identify whether the graph opens up or down and that you can find the vertex when it's in vertex form. And again, remember, if that number in front of the parentheses is more than 1, we have a vertical stretch. And if that number in front of parentheses is less than 1, we have a horizontal stretch or a compression where that graph gets wider. All right, I hope this helps. And again, if you have any questions, please let your teacher know.